What I want to do in this experiment is investigate the behaviour of a thermistor, which is a thermal resistor. So what we're going to have in this circuit is the thermistor, which is actually this at the end of here, at the end of this glass tube. So the thermistor is just here, and that's represented on this by this circuit symbol here. And I'm going to sit it inside a water bath, or a kettle in this case, and I'm going to measure the resistance. Now in this case, I'm actually going to measure the resistance directly using this multimeter. If I connect it to this setting here, I measure resistance directly, and that's called an ohm meter. So we're measuring resistance directly. So I'm going to put the thermistor into the water bath to start off with. And what I can do is I can gradually increase the temperature of the thermistor and measure the temperature of the thermistor against its resistance on the ohm meter. So what we can see is the thermistor is dipped into the kettle, and it's reading at the moment 6.4, and there's a little K there, so I know that's kiloohms, so that's 6,400 ohms at this temperature. And I'm going to use this digital thermometer to measure the temperature of the water, and then we can use that to get our results of the temperature versus the resistance of the thermistor. So as I heat the kettle, I just have to leave a little bit of time, so switch the kettle off after a few seconds, just to let the thermistor reach the same temperature as the water, because obviously the glass will take a little bit of time to transfer the thermal energy through it. So I'm now at 32 degrees, and I'm reading 3.89 kiloohms, so that's 3,890 ohms. So I'm just using the thermometer, I'm just stirring the water a little bit just to make sure that it's the same temperature. It's reading 52 degrees now, so this is my fourth result, and I've got about 1.98 kiloohms, so 1,980 ohms. I switch it on again for a few seconds, and I'm going to let it heat up. I'm going to try and get it up towards 100 degrees. It won't get to 100 degrees because it's not pure water, but we get close. But what you can see straight away is that as the temperature is rising, the resistance is going down. And you can see that clearly on here as well. This resistance is dropping off quickly on the ohm meter. So the kettle is getting close to boiling now. The last one we had was 85 degrees, and the resistance has dropped down from 6,000 to about 600. So it's about a tenth of the resistance. And as the water gets close to boiling, you can see that the resistance is still dropping. So we're down into the under 600 now, and we'll leave it till it actually boils and just get a temperature then. So the water is boiling now. The thermometer says that it's at close to 100 degrees. So we're reading, there we go, 98 degrees. And so we'll just record that temperature, just switch the kettle off. So we've got 98 degrees, and we'll just let the ohm meter settle at its lowest reading. So it's still going down, and we'll let it drop until it seems to level out. So it seems to have leveled out at about just over 390. So I'm going to write that down as 390.